In this video, we're going to take a look at how to evaluate indefinite integrals using U substitution. And the first example I have is the integral of 2 times 2x plus 4 cubed dx. So remember, the idea behind picking your u is that when you take the derivative, you have a constant of what we have left remaining. So here, if you chose to make u 2, the derivative would be 0, and that wouldn't help us. So in this case, we're going to use u is equal to 2x plus 4. And remember, when we take the derivative of this u function with respect to x, we have du dx is equal to 2. And then I'm going to multiply both sides by dx equals 2 dx. And now if you look, we have 2 and dx. And when we do our substitution, we're going to say that 2 dx is equal to du. So we're going to substitute du for 2 dx. And we're substituting 2x plus 4 for u. So now I'm going to rewrite it with our substitutions. We have the integral of u cubed du. And now we can use our power rule. So we add 1 to the exponent and divide by the new exponent plus our constant of integration. And now we need our answer to be back into our x variable, so we're going to replace u. So we're going to say that this is 2x plus 4 to the fourth divided by 4 plus c. In the next example, I have the integral of 8x to the fifth times 4x to the sixth plus 15, all raised to the negative 3. When you have two polynomial pieces, usually it's the one with the higher exponent, because when you take the derivative, then you get down to the lower exponent. So here, our u is going to be equal to 4x to the sixth plus 15. du is equal to 24x to the fifth dx. So now you can see that we have an 8x to the fifth in the problem, and we have a 24x to the fifth in our du. And what I like to do is move the constants to the other side of the equation. So I'm going to say that this is 1 over 24 du is equal to x to the fifth dx. And then in my problem, I'm going to move the constant to outside of the integral sign. So I have x to the fifth, 4x to the sixth, plus 15 to the negative 3 dx. And now we have negative x to the fifth dx is equal to 1 over 24 du. And we have everything on the inside of the parentheses is equal to u. And now we want to do our substitutions. So we have 4x to the sixth plus 15 is equal to u. So I have u to the negative 3. And then x to the fifth dx is equal to 1 over 24 du. And I'm going to put my du here, but I'm going to put both of my constants on the outside. So I had an 8 there already, and then divided by 24, because we had 8 times 1 over 24, or 8 over 24. And then I'm going to simplify that down to 1/3 during this next step. And now I want to take the integral of u to the negative 3. We add 1 to the exponent, u to the negative 2, divided by negative 2, plus our constant of integration. So now we can simplify this and say that this is negative 1 over 6 u to the negative 2 plus c. And now we need to put our u back to our x variable. So we're going to resubstitute, and we're going to have negative 1 divided by 6 to the 4x to the sixth plus 15 squared plus c. In our next example, we have the integral of x squared minus 4x divided by the square root of x cubed minus 6x squared plus 2 dx. And just like the last problem, we have two different polynomial pieces, so I'm going to look at the one with the higher degree. So I'm going to make u equal to x cubed minus 6x squared plus 2. And we're going to take the derivative, so du is equal to 3x squared minus 12x dx. And now, x squared minus 4x and 3x squared minus 4x aren't the same. So what I'm going to do is factor out a 3. So du is equal to 3 times x squared minus 4x dx. And then I'm going to move the 3 to the other side. So I'm going to say 1/3 du is equal to x squared minus 4x dx. And now when I do my substitutions, this here, x squared minus 4x, gets replaced with 1/3 du, and everything inside the square root gets replaced by u. So now let's do the substitutions. So we have the integral of, and I always like to put my constants on the outside, so this 1/3 du, I'm going to put the 1/3 on the outside. And then we have left 1 over the square root of u, and we could write that as u to the 1/2 du. And now I'm going to rewrite this in terms so that we can use the power rule. So I have 1/3 the integral of u to the negative 1/2 du, and now I'm going to use my power rule. So I have 1/3 times u to the 1/2 divided by 1/2 plus our constant of integration. And now we need to simplify this. So when we have a fraction over a fraction, we multiply by the reciprocal. So we have 2 times 1/3, or 2/3 u to the 1/2 plus c. And now we need to take it back to our x variable. So we have 2/3 times the quantity of x cubed minus 6x squared plus 2, all raised to the 1/2 plus c. And that's it for indefinite integrals using u substitution.